Hey there! So last time we created our first pipeline in Azure Data Factory that we used to copy data from customer table from Azure SQL database to a raw layer in our data lake. And it worked. But it had quite a lot of issues. For example, what if you would like to copy multiple tables, not only a single one, but many of them? Does it mean that you would have to copy all the objects we created so far? Well, it doesn't sound like a good design, right? So for sure, there must be a better way of doing this. And there is. Because ADF allows us to create dynamic pipelines. And that's the topic for today. So let's get started. Alright, so first let's take a look at our database that we have in Azure. But please note that I connected to it using Management Studio that is installed on my machine. So I'm connecting from my on-premises software to cloud using the tool that everyone knows. And here in our AdventureWorks, that's the database that we created previously, take a note that we have multiple tables. Previously, we loaded data from this sales customer table, but today let's make our solution better and let's try to actually ingest all of those tables. And instead of creating multiple data sets, multiple pipelines, let's try to be dynamic. So how to do this? Let's jump into whiteboard and let me start drawing our design. So let's start with the architecture or the design. So we start with Azure SQL database. That is our source. So that's Azure SQL database. And as you saw a minute ago, this time we'll focus on multiple tables, not on a single one like we did previously, but this time we want to ingest all of those tables. And it doesn't matter for us whether it's a 1 table, 3 tables, or 100 tables. Our solution has to be flexible enough to be able to process all of them. On the target side, or on the sink side, how ADF likes to call it, we still have our data lake. So this is ADLS Gen 2. And as a part of it, we've got our raw layer, which is implemented as a container, under which we would have some directories and then some files. So nothing changes on this side. All right. So how to do this? Well, you should remember from the last episode that usually we start with a linked service. And linked service is just a connection string that points to some object, like our instance of Azure SQL database. So for sure, we will need a linked service. Linked service. And previously what we did was to configure it in a way that it indicated our instance of Azure SQL database. This time, let's make it dynamic. Let's try to implement it in a way that we could use this linked service to connect to any Azure SQL database, not only to the one that we hard code. So let me draw it like this. That our linked service, it will just point to some Azure SQL database. And now, at the design time, when we are implementing the solution, we might not even know what database we want to connect to. We will know that at runtime, and that's possible. So that's the linked service that has to be created. Then on the target side, we obviously also need a linked service. So let me write it down, linked service. And here, just for simplicity, let's reuse the linked service that we created previously. That was hard-coded to indicate to our data lake. We could make it dynamic as well, but let's keep it simple today. Alright, so once we have the linked service, the next thing we need is a dataset. And you should remember that dataset is just a representation of our data. So, like so, dataset. And what we did last time was to configure our source dataset in a way that it pointed to our customer table. So it was tightly bound to our specific table. But it would mean that actually, if we continue doing this datasets in the same way, we would have as many datasets, as many tables we want to ingest. And you can imagine that in time, we might end up with hundreds of datasets, which is not a good design. So again, here, let's make our dataset generic or dynamic. So we want to have a generic dataset in which we will tell ADF, hey, dear ADF, this dataset, it will be used to represent some data read from Azure SQL database. But at this moment, at the design time, we don't know what table it will be or what query it will be. We don't know what columns this dataset would store, what data types, how many rows. We don't know this. All we know is that it will be used to store some data read from Azure SQL database. And that's enough. And we will configure it in a way to work with our generic or dynamic linked service. Like so. Now, on the target side, we also need a dataset. So let me create it. So dataset. And can we reuse the dataset that we created previously? Not really, because it pointed to a specific file in our data lake. And this time we would like to reuse it for every table that we process. So it means that it has to be dynamic as well. So like in case of source dataset, this dataset has to be quite generic or dynamic. And here we will tell ADF something like this. Dear ADF, this dataset on the target side, it will be used to save some data on a data lake. But again, at the design time, we don't know what data it will be, what columns. And actually, at this moment, we don't care. And it will work, trust me. All right. So that's linked service and datasets. Then to connect all this stuff together, what we have to create is a pipeline. So let me try to fit our pipeline in the middle. So pipeline. And pipeline is again just a logical container for our activities that we want ADF to perform. And last time we created a single copy activity that used source and target datasets to copy data from customer table to some file on a data lake. But this time we want to make our pipeline dynamic. We want it to be able to process all tables, not a single one. Which means that we have to change its design. And actually, we would start with a new type of activity that is called Lookup. Lookup activity that will connect to our database, and we'll use it to query this database for a list of all tables. Because today the goal is to process all tables that are stored in our Azure SQL database. Alright, so let's stop here and let's start implementing this stuff. So let me jump to Azure portal, to Data Factory. And actually, this time, let's start creating the solution from our pipeline. So let me add new pipeline. And let's call it dynamic pipeline, because we want it to be dynamic. Dynamic pipeline. Let's hide this place. And now we have to start with the lookup activity, the thing that we designed in our whiteboard. So if I start typing lookup, you will see that we have this activity under general category. So let's drag it to our canvas. And now in lookup activity, let's configure some properties. Many of them I will leave as default, which is not a good practice, but again, just keep it simple. We'll revisit those various properties in future episodes. So let me give a name to our activity, like get a list of tables to be processed, just to give some more meaning to our activity. Then in the settings tab, we have to configure our lookup. So basically, we have to tell ADF what we want to do. And here we've got to select some dataset that will be used as a source for our data. And right now, we have only those two datasets that uses hard-coded customer data. And in our case, it won't work because actually what we want to have is a dynamic dataset. So let's create a new dataset. And this lookup activity, we want it to connect to our Azure SQL database to get a list of all tables. Which means that as a type of our dataset, I have to use Azure SQL database, like so. Let's give a name to our dataset, like dynamic or generic Azure SQL DB dataset. Then we've got to associate our dataset with some linked service. And actually, let me create a brand new linked service that we want, that will configure in a way that will be able to connect to any Azure SQL database. So let's call it generic Azure SQL DB linked service. And now, previously, what we did was to use these drop-downs to explicitly indicate which instance of Azure SQL database I want to connect to. But here we want to make it dynamic, so we won't specify the database right now at design time. Instead, what we'll do is to add two new parameters to our linked service. So the first parameter I want to add is a server name of a string type. And UI is extremely slow today for some reason. And let's add a second parameter called database name. Database name. Again, I made a typo, so let's fix this. Database name of string type without any default values. And the question is why I created those two parameters. Well, simply because when we are configuring our linked service, we've got to provide the server name and a database name to which we want to connect. But to make it dynamic, let's switch to enter manually option. And here, instead of hard coding the value, take a look that at the bottom, we've got this nice blue link called add dynamic content that allows us to configure this property programmatically. So the value will be evaluated at runtime, not at the design time. And here, if I click on it, you can see that this nice pipeline expression builder window was opened. And here I can write my expression that again will be evaluated at runtime. And I have those two parameters available that I've just defined. So let's simply use the server name. And you can see that it automatically populated the value, the proper extension. So as a result, the value of this parameter that we've just defined will be used as a server name. So let's do the same for database name. So let's parameterize it. And here we want to use database name parameter, like so. And for authentication type, for now, let's stick to this ugly SQL authentication. There are better ways to do this, but for now, for simplicity, let's use SQL authentication with this hard-coded user, which again is a bad practice, but for today it will be enough. All right. So our linked service is created. Let's just wait for the UI to understand that I typed the password, and let's create it. And please don't crash. It's creating. Fingers crossed. All right. So the pipeline linked service has been created. Now, at this moment, I can't even indicate a specific table to which our data set should connect to, simply because we didn't provide any value for server name and parameter name and database name, so ADF is not able to get a list of those tables. And that's fine, because we will set it at runtime. So basically, that's it. So that's our data set and our linked service. So let's get back to our drawing. So what I did a second ago. So basically, we created two parameters, server name and database name. Database name. And they were created at the linked service level because, well, that's the place where we define the connection string. So for sure, they have to exist there. But now we have to somehow pass values from our pipeline to this linked service, values of those two parameters. So let's think how it could be done. So let's get back to our lookup activity. So we defined what dataset is to be used. That's our generic dataset. That's great. But now, come on, please. Let's open our dataset. Take a note that actually it detected that we are using this generic linked service that expects those two parameters. And that's right. Our linked service expects server name and database name. And we have to provide those values somehow. So how to make it work? Well, simply in our dataset, the generic Azure SQL database dataset, let's create such two parameters, and we'll use them to pass values to the to linked service. So right now, I'm in a dataset designer, and let's create those two parameters, server name and database name. All right, so those two parameters are created at the dataset level, and let's use them to pass values to the linked service parameters. And again, we can use those dynamic expressions like so. So as a server name, we want to use the server name parameter that was defined at the dataset level. Oh, come on, please cooperate, like so. And for database name, we'll do exactly the same. Let's use the value of our database name parameter. All right, so that's good. So what we did? So in our generic dataset, we created again those two parameters, server name and database name. And we simply configured our lookup activity to pass those parameters to the linked service. So that's fine. Now the remaining thing we have to do is to set the values in our dataset. Because right now what we are doing is just passing the value, but we didn't set the actual values anywhere yet. So in our pipeline, if we click on our lookup activity, take a look that, that dataset detected that because we are using our generic dataset, it has those parameters defined, so we have to specify them, right? The problem is that UI has some kind of issue because it detected only a server name parameter, but actually we created two parameters. But we'll fix that in a second. So how to make it work? Well, let's go to the highest object in our hierarchy, which is the pipeline. Let's create two parameters at this level. So again, let's create our server name and database name, and here let's provide default values. So our database was called AdventureWorks, and for the server name, let me jump to our SQL server, and that's the value. That's the value of our server that we have to use. So let me copy it, and let's paste it as a default value in the pipeline. So again, let's jump back to our drawing. So what I did. So I created those two parameters at the pipeline level. So we've got server name and the database name. And here we created defaults values for them. Plus defaults. All right. And now what we have to do is to use those values defined at the pipeline level and pass them to our dataset parameters. And we'll do this by using our lookup activity. So it would work like this. So the values that are defined at the pipeline level will be passed through the lookup activity to our dataset, and then from dataset to our linked service. And if I didn't mess it up, then everything should work. All right, so let's get back to our lookup activity and let's configure this parameter. And here I want to configure it as a server name parameter that was defined at the pipeline level. So one more time, server name. All right. And now let's fix the issue with UI that only a single parameter is being displayed. So to fix this, let me switch to the code view of our pipeline, like so. And as you can see, this is just a JSON file, and we know what JSON is. So let me try to find our parameters at the dataset level, and that's the definition. And here we've got only a single parameter defined. Oops, come on. So let me copy this part and let me paste it. All right. And let's change the name of the parameter to database name. The value is obviously wrong, but we'll fix that in a second. All right. And hopefully this time, yes, this time ADF finally knows that our dataset expects two parameters, server name and database name. And the value of database name is wrong because we copied the value from the server name. So let's fix it. And let's set it as a database name parameter. All right. So the connection has been hopefully configured. The next thing we have to do is to actually define a query or a stored procedure or a table that we want to get from our database. In my case, I have a query that I will execute in Management Studio to show you what it does. All right. So this is just a very simple query that queries system tables inside a database and retrieves a list of all tables and schemas they are in. So basically, our database contains 12 tables. And the lookup activity is meant to retrieve those 12 tables because later on we would like to dump data of all of those tables to our files in a data lake. All right. So in the lookup activity, let's switch to the query mode. Let me paste the value of our query and let's test whether it works. So let me click on this preview data button and hopefully we will see some data. And here you can see that we defined those two parameters at the pipeline level. So when I want to preview the data, I have to provide values for them. But because I set default values at the pipeline level, I don't have to type them over and over again. So that's quite handy. So one more time, let's preview the data. And let's see whether we'll see anything. And yeah, it worked. So we see some data retrieved from a database, that we have a customer table from sales schema. The problem is that we got only one row, and in the database we saw that we got like 12 tables. So let's fix this. And this is caused by this first row only property inside the lookup activity that by default is checked. So let me uncheck this to get all data from our lookup, and let's preview it one more time. And yeah, so we've got this nice table of all tables that exist in our database. So that's great. So let me publish the stuff that we created so far, so we don't lose it in case of any issues. And before we go any further, let's actually debug our pipeline, because I want to show you how the data returned by the lookup activity actually looks like. So in the preview data option, we saw this nice table, but it doesn't mean that the data looks this way. It was just created, displayed this way for us, for humans. But when I debug the pipeline, you can see here those two icons. The first one shows inputs to our lookup activity, and the second one shows what comes out from our activity. And we want to see the output. And here you can see that actually what the lookup activity gives us is, again, it's some kind of a JSON data. And the information that we care about is stored in this value element, and this is an array of JSON objects, like so, and each of them contains those two properties called table name and schema name, and it has our data. And the question is, why does it have this table name and schema name names? Well, simply because that's what we configured in our query. So where's the query? It's here. So we defined explicitly data returned by database as table name and schema name. So that's why they are called this way in the output JSON. All right, so we are halfway there. So let's get back to our drawing. So now what we have in our pipeline is a list of tables we want to process. But now let's actually process them. Let's start copying our data. And to do this, we'll use two activities. The first one is a for each activity, which, as you can guess, is used to iterate over a list of elements. And in our case, we will iterate over a list of tables that was returned by our lookup activity. And inside for each loop, we would have again a copy activity that will be used to copy data from given table to some file in a data lake. So let's implement this part of the solution. All right. So let's jump back to our pipeline and let's try to find our for each activity. And here it is under iteration and conditionals. So you can see that actually inside ADF, inside our pipelines, we can have some kind of a logic implemented, some control flow. That's what we are doing right now. So let's drag this for each activity. Let's connect these two activities using this green arrow, which represents on success connector, which basically means that for each activity will be executed only after the lookup succeeded. So let me rename the for each like iterate over all tables. All right. Now, the most important thing in the for each activity is to configure a list of items over which we want to iterate. And again, we could hard code it, just provide some values here manually, but that's not what we want to do. We want to make it dynamic. So again, let's make use of this blue dynamic content expression builder. And here we have to specify all those values that were returned by our lookup activity. And now the great thing about ADF is actually that in any task we have access to output of every previous activities, which means that here in our for each activity we can refer to the output of the lookup activity. And that's what we want to do. And for this purpose, we've got this special tab in our expression builder called activity outputs. And right now we have all those outputs from the lookup that we could use. And now the question is which one to use, right? But fortunately, I remember that the data that was returned by the lookup, it was an array. We saw that when looking at the JSON. So most likely the last one, which tells that it is an array of raw data, is what we have to use. So let's simply click on it, and it resulted in creating this expression that refers to our activity, to its output, and then to the value. All right, and did it save? No, because I clicked escape, like so. All right, so this is done. So our for each will iterate 12 times because we have 12 tables in our database. So now let's create our copy activity. So let me go into our for each activity. And now the canvas that is displayed here, it represents the contents of our for each that you can see just by looking at the path at the top. So let me drag our copy data activity. Copy data from table, like so. All right, So now what we have to do is to specify a source and a sink, source and target of our data to be processed. And now that's the complex part, because we can't hard code a specific table here. No, we have to make it dynamic. So in the source, we have to use some kind of a dynamic dataset. Fortunately, we've just created this generic dataset that we previously used to query our database to get a list of all tables. And it's perfectly fine to reuse it here, because this dataset was meant to just store any data read from Azure SQL database. And here in the copy activity, that's what we want to do. We want to read the contents of our table and then dump it to a file. So this dataset should work in our case. Now, this dataset has these two parameters that we have to define: server name and database name, because ADF has to know to which instance of database we have to connect to. So let's configure it. Fortunately, we have those parameters created already at the pipeline level, so let's use them. So let me switch to the parameters tab that shows parameters at the pipeline level, and let's simply configure those two dataset parameters to receive values that were specified at the pipeline level, like so. So what we did? So in our copy activity, I said, dear ADF, as a source, please, let me change the color, please use this dataset and use the value of database and server name that was provided as a parameters for the pipeline. That's great, but actually this is only a connection string to a database. But now we have to define an actual query that we want to execute, or specify a table to which we want to connect. So let's do this. So let me switch to the query mode, and let's actually create a dynamic query. And why dynamic? Because simply in our for each loop, in every iteration, we will refer to a different table, the one that was returned by a current iteration of our loop. And fortunately, we've got this current item object from for each iterator that is represented as item that represents the current value from our loop. So we'll use it. So let me paste the query that I created previously, and let me explain what it does. So basically, I'm using concat function that concatenates strings. So I start with this hard-coded select star from, that's the first part of the query. Then I refer to the schema that was retrieved by the current iteration of our loop, dot, and then the current name of a table. So let's save it. So basically, it might look like this, that in every iteration of our loop, the query that would be executed against our database would be something like this. Select star from, let's say, sales lt.customer. In the next iteration, it would be select star from sales, I don't know, address, or whatever whatever tables we have there. So that's how it would work. It would be dynamic. All right, so that's the source side. We know what data we want to read. Now we have to define where we want to save our data. And again, we want to make it dynamic. Previously, in the previous episode, we manually created this folder in a data lake that represented a server name, then database name, and then year, month, and ingestion date. This time, let's do it automatically. And we will need some kind of a generic data set that could be used to save data on a data lake. At this moment, we don't have any yet. So let's create a new generic data set that would be used to save data on a data lake. And we want to save it as a CSV, just to be able to read the file in an easier way. Usually I would save it as Parquet, and I advise you to try it out if you're following along. But right now, let's save it as CSV, and let's call it generic ADLS Gen2 CSV dataset. We've got to select some linked service, and the one that we used in the previous episode that uses this hard-coded data lake is fine for today. We could make it dynamic, but let's just leave it as it is. Now, we want to have the first row as header, for sure, but the issue is that we don't want to provide a hard-coded path to the file at this moment, because the path, it depends on the data that we are copying. And unfortunately here, we don't see the possibilities to use expressions. So for now, let's leave blanks here, like so. And let's go to the data set using these open functionalities and take a look that actually here I can define those expressions in every place. So the same data set, but previously in the previous window it was static. Here we can make it dynamic. All right. But if we want to make it dynamic, actually we have to have some kind of parameters for this data set. So we have to add some parameters. And let's now think what kind of parameters we might need when we are saving data to a data lake. So again, it depends how we want to structure our data. So let's say that actually I want to have it like this. In a row container, then let's create a directory for a server. So for sure, we will need a parameter for the server name. Then I want to have a directory for database. So again, this has to be parameterized. And then I would like to have, let's say, ingestion date, like year equals something, then month, and then day. And finally, at the bottom, I would have files, CSV files. And to be able to distinguish different files, I would like to use, I would like to name them in a way that, actually, let's use schema underscore table as a naming convention. So we would need those two parameters, schema and table, available in our dataset. So let's create those four parameters on a dataset level. So we need server name of string type. We need database name, database. We need schema, the database schema from which we ingested our data, schema name, and we need a table name, all of string types. All right, so these are parameters. So let's use those parameters inside our dataset. So the top level container, it is raw. We don't have to parameterize this. Now for directory, yes, we want to parameterize this. And let me copy my expression. All right, and let me explain what it does. So here I'm concatenating different parameters, like the server name that was retrieved from a parameter, database name, and then I'm creating this structure year, month, and date based on the current date, which I'm just formatting by year, month, and day. And these slashes are used simply to tell ADF that we want to create this as separate directories. All right. And as a file name, again, let's make it dynamic. And here, let me again use concatenation function to name the file as schema name underscore table name .csv. All right, that's great. But what we are missing is actually passing those values to a dataset. What we did so far was to create 4 parameters at the dataset level. So like so. And we have those server name, database name, and table name and schema name. And obviously we have to set their values. In case of 2 of them, it's pretty easy, because for database name and for server name, we could use the parameters defined at the pipeline level. But for the schema and table, we can't do this because such parameters at the pipeline level, they don't exist. But because our copy activity is inside our for each loop, and in every iteration of the loop we have access to the current item, we can use those values from the loop, right? Because in every iteration we know exactly what table we are working on at this moment. So let's configure this. So in our copy activity, let's set values for the server name and the database name. So for these 2, that's pretty easy because we have those parameters defined. So for server, we would use server name parameter. For database, we would use database name parameter. And for schema and table, well, we have to refer to the current item from the loop that is represented by this item property. Then, if you remember the structure of the data returned by lookup activity, it had this schema name and table name properties. So let's start typing, and yes, in this case, as a value of schema name parameter, I want to use the schema name property retrieved from the current iteration of our loop. And let's do the same for the table. So let's start with the current item and then table name, like so. So it should work. Let's publish everything. Let's see whether that would work. And before we execute our pipeline, let's verify what we have currently in our data lake. So previously, we saved data from the customer table, and we used this table SQL Server directory under row container, and it was created the structure manually. This time we want it to be created automatically. So let's execute our pipeline and let's see what happens. So let's provide values of our parameters, and because I specified the defaults, I didn't have to type them in. And now the pipeline is being executed. So it starts with getting a list of all tables that we want to process, and we can already see at the bottom that it already started iterating over those tables. So we have a copy data activity created for every table that was retrieved by the lookup. And actually it already finished, right? We can see those all green check marks. So let's take a look at our data lake to see what happened. And yes, so we have new directory, this one, that uses the name of the server from which data was retrieved, because that's how we configured the target dataset. Then we've got AdventureWorks, because that's the name of the database from which data was retrieved. Then we have data partitioned by current date, by the date the data was ingested. So we've got split on year, on month, and day, and it was created automatically. And finally, we've got like 12 files, CSV files, each of which contains a data from a specific table. So for example, this sales LT underscore customer, I would expect it to have some customer data inside this file. So let's verify how it looks like. And yeah, it worked. So we have the header as the first row, and then we've got some customer data. Let's take a look at address file, just to verify that it really contains a different set of data. And yes, here we've got address data, so it looks to be working. Let's take a look at products. And yes, in this file we've got products, so it worked. So take a look. Just by using those three activities, lookup, for each, and copy, and those dynamic linked services and datasets, we were able to create this very flexible pipeline that is able to connect to any database in Azure and grab all tables from it. So it's very easy to ingest the data. Now, this pipeline is not perfect yet. It still has some issues. For example, in our source linked service, we use these hard-coded credentials that we use SQL authentication with Piotr as a username, which is pretty bad. The same when it goes to the target linked service, the way we authenticate to a data lake is terrible. But think about possibilities that these dynamic expressions give us. It's huge. So here, let's say that instead of just getting all tables that we want to ingest, we could create some kind of a configuration table somewhere, inside which we would specify which tables we want to ingest. Secondly, in our copy activity, where is my copy activity? It is here. Take a look at the query we are executing. Oh, come on. Where is my query? Query, yeah, it is here. So I'm using select star from table. So every time I just retrieve all rows from given table, which in many cases is bad. Because why do we want to keep retrieving every row every day? What's the point of doing this? Maybe it would be a better idea to make this query incremental. So instead of grabbing all rows, maybe we would want to add some where condition and filter the data, let's say based on last update date. So if we run the pipeline tomorrow, we would get only those rows that were changed since the last time we executed our pipeline. And because in those expression builders, we can create basically whatever expression we want. It's up to us to define the logic based on which we would decide whether for table A we want to load it incrementally based on some column, but maybe for table B we want to load it fully. It's up to us. But those expressions, they give us a lot of flexibility. So think about it. And now, if you want to practice this stuff, please create such pipeline in your environment and think about a small change. Because here, I dumped all files to a single directory. Maybe that's fine, maybe it's not. So as a task for you, please try to change the structure on a data lake. So instead of server database year, month, and day, please add here a dataset name. So for example, we would have server database, then customer, and then year, month, date, and at the very bottom you would have customer file only. The same for address, for product category, and so on. Alright, and basically that's it for today. I believe you should now feel how powerful those expressions are in Data Factory and how many possibilities they give us. Instead of hard coding stuff, which is usually a bad idea, we can make our pipelines and processing dynamic. So that's it for today. Thanks for watching and see you soon. Take care.